Hey guys, welcome back to the continuation of electrolysis. We are done with the basic concepts of electrolysis, and afterwards, we have practiced some of the compounds which were electrolyzed in their ionic state. Here, I'm going to practice one more compound, and that is called lead bromide, electrolysis of molten lead bromide. It is written in your syllabus as it is. Okay, electrolysis of molten lead bromide. Okay, PbBr2. Okay, now the point is this, that what are the ions here? First of all, it is Pb plus 2 and 2Br1 minus. There will be no water as it is in the molten state, so Pb being positively charged will move towards a negatively charged electrode. And what is the name of the negatively charged electrode? It is called cathode. It is called cathode. And at the cathode, what is happening? This is reduction, which is happening at the cathode. And what is reduction? It is gain of electron. Now, if we are writing about the Br, it is positively charged, it is moving towards the positively charged electrode, and being negatively charged ion, it will be attracted towards the oppositely charged electrode, which is positively charged electrode. And what is the name of that positively charged electrode? That is called as anode. And at the anode, there is an oxidation. And what is oxidation? Oxidation is loss of electron, loss of electron. Now I can say you that what will be the charge on Pb? It is Pb plus 2. Okay. So Pb plus 2, it means that by gaining 2 electron, it is going to shift itself into Pb, the metal atom. Okay. And in this case, it is 2Br already here. So 2Br, 2 bromide ions are there. What they are going to do, they are going to lose 2 electrons, and after losing 2 electrons, they are going to shift themselves into Br2 molecule. Okay, now what is the observation here? Number of electron gained and lost are equal, so we are going to cancel the electrons. Before writing the observation, I would like to write down the sum up equation. It is Pb plus 2 plus 2Br1 minus 2Br1 minus arrow Pb along with Br2. Okay, what is the observation in this case? I'm writing with another color so that you people may not mix the things. Look at here right now. It is Pb, and what is the color here? I have told you that you are going to consider every metal silver gray in the color. Every metal has silver gray color except for the copper, which is pink, red, or brown in color, and the gold, which is golden in color. Rest of all metals you are going to write like this. Okay, so what you are going to write: silver gray metal deposited, metal is observed, metal is observed at where? At cathode. Okay, at cathode. And what about the Br2? This is very important as it has a very different type of an observation. So what is the observation for this? It is, you may say, red brown fumes, red brown precipitates. You may say red brown fumes are observed at anode. Red brown fumes are observed at anode. So this is the observations related to the molten lead bromide electrolysis. As it is molten, so it means it has no water in it. Okay, now we are going to write down the electrolysis of solutions. Okay, of diluted solutions. Okay, so first of all, you should know this thing, that in case of electrolysis of solution, there are two types of the cases. Electrolysis of solutions. Okay, now there are two types of the cases. Before two types of the cases, you should know this thing, that what is the meaning of solution. It means that water is added. Water is added, hence water ions are involved. Water ions will participate, they are involved. Okay. Now, point number two is this, that you should know what are the water ions. So, water ions are of two types. One of them is H plus one, which is called as hydrogen ion, and the other is hydroxide ion. So, these are the water ions always. So, this will be the conversion of water always. Okay. So, solution is of two types. One of the solution is called as diluted solution. Diluted solutions just mean that lots of water is present. Okay, and small amount of the salt is added. diluted solution, sorry bache. So this is now the concentrated solution. What is concentrated solution? Which is called an aqueous solution as well. Aqueous solution as well. In this case, lots of salt is present, higher amount of compound is present. Higher amount of compound is present. Okay. So I have told you both of the names for the concentrated. It can be concentrated, it can be an aqueous solution as well, whereas diluted is the one and the only which has lots of water present in it. Okay. Now I am giving you an example for the electrolysis of sodium chloride aqueous solution. Or first of all, we should do the diluted solution. Electrolysis, electrolysis of diluted solution of sodium chloride. Okay. Guys, before moving ahead towards the diluted solution electrolysis, let's consider what are the reactivity series of ions. Okay. Reactivity series of ions. Now, there are two types of the ions. One of them are positively charged ions, and the other is negatively charged ions. And you need to keep both of the series in your mind. Yes, okay. Now, what are the positively charged ions? So, it is basically we are going to start from the group number one. We are going to write group number one in the inverted way. We are going to neglect francium, rubidium, and cesium as they are super reactive, so they are not going to discharge. Rather, we should say they are never going to discharge because of their super reactivity. As far as the discussion is related to francium and radium of group number 1 and 2 respectively, we are mostly not discussing them. Why it is so? Because they are the radioactive elements. Radioactive elements are emitting radiations out of them on their own. They don't need any external environment for that. They don't need oxygen and water for that. They are emitting radiations like they are emitting protons or electrons or neutrons, and they are converting themselves into an other substance. They can convert themselves into an other element as well. So sometimes they are emitting beta radiations, alpha radiations, etc., etc. These are specific type of radiations which we will teach you in the topic of radioactivity in the future. You may say when you will do this chemistry in the extended version after your A levels, we are not going to teach you this radioactivity in your A levels as well. So I'm just letting you know that radioactive substances have been discussed with you when I have taught you about the third isotope of hydrogen, which is called as tritium. It is a radioactive isotope of hydrogen which is used for the cancer therapy. Okay. So here I'm writing this is sulfate, here SO4 2 minus, nitrate, here NO3 1 minus, PO4 3 minus is phosphate. Then it is chloride, bromide, and iodide, and then last one is hydroxide. Okay, these are the series of the negatively charged ions. Whereas when we are talking about the positively charged ions, it is we are going to write the top ones here. So we can write the lithium, sodium, and potassium. Okay, these are enough to tell you about the group number one. If we are talking about the group number two, we can say it is beryllium, magnesium, calcium, and strontium. Okay, we are going to write till this. We are omitting the remaining because they are super reactive, so they are not going to react. So this is beryllium, Be2 plus. Okay, now I'm on the third group, that is called aluminum is the representative of that, and here is hydrogen, copper, it is carbon, it is zinc, it is iron, it is tin, it is lead, it is hydrogen. I am writing these in the brackets, copper, and then afterwards it is silver, and then gold, and then platinum. Guys, please don't forget this thing, that how to write the charges on them. It is copper, which is +2, it is silver +2, gold +2, and platinum +2. So let me tell it to you very clearly that to which groups these are belonging. Okay, so if I'm telling you this is part of group number one, this is part of group number two, this is part of group number three, this and this are the non-metals. What about zinc and iron? These are the transitional block elements. So TBE represents transitional block elements. Tin and lead are group number four, whereas copper, silver, copper, silver, gold, and platinum are also transitional block elements. Okay, so this is how the reactivity series are written. Okay, one thing which I would like to inform you, higher is the position in the reactivity series, higher is the reactivity of that ion. So according to that, if you are looking into the reactivity series of the positively charged ion, potassium has the highest reactivity, whereas platinum has the lowest reactivity. As they are highest in the position, potassium is highest in the position, whereas platinum is lowest in the position. Okay. Let's discuss about the negatively charged ion. Yes, in the negatively charged ion, same rule is applied. Higher is the position, higher is the reactivity. Sulfate has the highest position, highest reactivity. Hydroxide has the lowest position, lowest reactivity. Now I am telling you very clearly for these, never discharging. These three are never discharging. Now what is discharging? Okay. Discharging is basically movement of ions from the solution to the electrode and performance of the chemical reaction at the electrodes. What are the electrodes? Electrodes are the specific type of the places, specific types of the, you may say, the attachments, you may say, with the positively charged and the negatively charged terminals of the battery, from where electrons are either going or losing, either coming or going, you may say, and due to their come and go process, reactions are involved. Okay, electrons coming and going is involving the reaction. So we can say this thing, that reactions of electrolysis are happening on the specific surfaces which are called as the electrodes. Back to the term of discharging, let me tell you one relationship. Okay, discharging is inversely proportional. Discharging is inversely proportional to reactivity. What is the meaning of this? Reactivity means higher is the reactivity of the ion, higher is the position of the ion in the reactivity series, higher is the reactivity of that ion, hence lower will be the discharging, and vice versa, and opposite. Okay, so we can say this thing, that according to this reactivity series, potassium has the highest reactivity, hence it has the lowest discharging rate, whereas platinum has the highest discharging rate, whereas lowest reactivity. In the same way, hydroxide has lowest position, so it has the highest discharging. Lowest position means lowest reactivity, hence it has the highest discharging rate. I am repeating my words regarding discharging. Discharging is the process in which the ions are being attracted towards the electrode, are being attracted towards the oppositely charged electrode, and then they are performing a chemical reaction there. So, for example, if we will have two positively charged ions and two negatively charged ions, there will be a competition between them. There will be a competition between the two positively charged ions, and there will be a competition between two negatively charged ions. Both of the positively charged ions are running towards the negatively charged electrode, and both of the negatively charged ions are running towards the positively charged electrodes. Out of the two positively charged ions and out of the two negatively charged ions, only one ion will be able to perform the chemical reaction at the electrode. So this whole process is called as discharging. Today we have discussed this thing, that what is the solution and what type of the solutions are there, and then we have discussed about the reactivity series and the discharging as well. I'm going to continue in the next lecture, inshallah, from the concept of the diluted solution of NaCl, and we are going to practice two or three more solutions of the solutions of diluted nature, so that you people may have a better idea about the electrolysis of the diluted solutions. All right, guys, thank you very much. See you in the next class.